In this video, we're going to do some examples of problems with annuities that you might see in your homework. So here's the formula for an annuity. Here we go. A equals R times the fraction here, 1 plus R over M, all to the MT minus 1, all divided by R over M. Okay, so let's look at the first example. David puts $350 a month into an annuity, paying 6.5% interest compounded monthly. How much money will be in the account in 15 years, and how much of that is interest? Okay, so it says that he's using an annuity, so we know that we need to use the annuity formula. You should write that down. Oops. A equals R times 1 plus R over M to the MT minus 1, all divided by R over M. And now we want to identify what we know. So $350 a month, that's my big R, capital R. 6.5% interest, so little r is 0.065. Make sure you move that decimal 2 places to the left. Compounded monthly, that tells me my M is 12. And it wants to know how much money will be in the account in 15 years. We don't know A, and 15 is my T. All right, so let's plug it all in. A equals 350 times 1 plus 0.065 over 12 to the 12 times 15 minus 1 divided by 0.065 over 12. Now you should be able to type this whole thing into your calculator. So go ahead and type that into your calculator. If you need to, pause the video so you can do that. I've already typed it into my calculator, and what I get is $106,240.67. So this is the amount in the account. So that answers the first question. The second question was to know how much of that is interest. All right, so interest is the extra that you get on top of what you've put in. So we first need to figure out what we've put in. Let me use a different color. So we've put in $350 a month for 15 years. So $350 times 12 times 15 is $63,000. So the interest is going to be the amount in the account, A, minus 63,000. And I get 43,240.67. Make sure that you agree with that. Okay. All right, so that's sort of the first kind of problem that you might see with annuities. Let's look at another problem. Maria wants to have saved $4,500 in a sinking account in 6 years. A sinking fund, that should say. If the account pays 7.2% interest compounded monthly, what should her monthly payment be? Okay, so again, with a sinking fund, that's an annuity. So we know that the formula we need to use is the annuity formula. A equals R times 1 plus R over M to the MT minus 1 over R over M. Let's identify what we know. So this $4,500 is the amount she wants to have at the end. This is my A. In 6 years, so that's my T. The account pays 7.2% interest, so little r is 0.072. Compounded monthly again, so M is 12, and it wants to know what should her monthly payment be. So R is what we don't know. All right, so let's plug it all into the formula. 4,500 equals R times 1 plus, 0.072 divided by 12 to the 12 times 6 minus 1, all divided by 0.072 divided by 12. All right, now we need to solve for R here. And what we have is R times a fraction. So how do we remove that fraction? We multiply by the reciprocal of this big fraction here on either side. Okay? So when I do that, what I get is 4,500 times the reciprocal of that fraction. So 0.072 over 12 over 1 plus 0.072 over 12 to the 12 times 6, which is 72, minus 1 equals R. Now this is what you need to plug into your calculator. So go ahead and take a second to plug that in. And you should get 50.15. So if she puts $50.15 in every month, then after 6 years she'll have $4,500 in the account. All right, I want to do one more example. And this is the one that takes a few more steps, okay? So we want to make monthly payments of $450 into an annuity paying 8.6% interest compounded monthly. How long will it take for the amount in the account to reach $60,000? So this question is asking us for time, right? How long? Okay, so T is what we don't know. We're making monthly payments of $450, so $450 is my R. 8.6%, so little r is 0.086. Compounded monthly, so M is 12. And we want to end up with 60,000, so A is 60,000. All right. It tells us it's an annuity. We also know it's an annuity because we're making monthly payments. So we want to use the annuity formula. For the sake of space, I'm going to assume you have that formula in front of you. So let's just plug in all our variables here. So I've got 60,000 equals 450 times 1 plus 0.086 divided by 12 to the, so it's to the MT. Let's just call that N for now because we don't know T. We'll solve for N and then we'll solve for T. So minus 1 over 0.086 over 12. Okay, so our goal is to get to that N. We've got to work from the outside in, removing the things in our way. So the first thing in the way is this 450. It's multiplied, so to undo multiplication, we divide. So now I have 60,000 divided by 450 equals 1 plus 0.086 over 12 to the N minus 1 all over 0.086 over 12. Now the next thing in the way is this denominator right here. And so to remove the denominator, we're going to multiply by it on both sides. Okay, so I'm going to multiply by 0.086 divided by 12. It cancels on the right. Okay, so on the left I have 60,000 divided by 450 times 0.086 over 12 equals 1 plus 0.086 over 12 to the N minus 1. All right, what's the next thing in the way? This 1. And so how do I undo subtraction? I need to add. Okay, so let's add 1 on both sides. I'm going to turn the page. Oops. Here we go. All right, so now I have on the left 60,000 divided by 450 times 0.086 over 12 plus 1 equals 1 plus 0.086 over 12 to the n. Okay, so now we're in a good place because we've got the thing with the n by itself on the right. Now n is in the exponent, so we need to use a tool to pull it down from the exponent, and the tool we want to use is the natural log. So I'm going to take the natural log on both sides, right? And that's going to let me pull this n down front. So now I have natural log of 60,000 divided by 450 times 0.086 over 12 plus 1 equals n times the natural log of 1 plus 0.086 over 12. I'm trying to solve for n. It's multiplied by this natural log on the right, so undo multiplication, I need to divide. So divide by the natural log of 1 plus 0.086 over 12. All right, so if you plug that into your calculator, take a second, maybe pause the video if you need to, and plug that in. What you should get is 93.91740,197. Now remember, n is the total number of payments, so you'll have to make approximately 94 payments to reach your $60,000. Now, if we want to know how long, we need to solve for years. Remember, n is m times t, and in this case, m is 12. So to solve for t, I'm going to divide both sides by 12. This number should still be sitting in your calculator, so just hit divide by 12, and you should get 7.826 years. So it'll take approximately 7.826 years for the account to reach $60,000. All right, these are 3 of the most common kinds of problems you'll see with the annuities. Please practice these at home and use this video as much as you want to review these kinds of examples.